Okay. Hello, everybody. We will wait a few minutes before we start. The room is open now. Hiya, Tobias. Okay.
I tried already to share my screen. I guess it worked.
Yeah.
Perfect.
And what I can see, more and more participants are still joining us. I think we will wait another 2 minutes before we start. Okay. Okay. I think we should start now, Tobias. What's your opinion?
So I think just in this moment, still people are joining and not too less. So maybe,
okay, yes, you are right. Now we.
so maybe another minute.
Okay. And then we can all start together. Yes, we have a big group of participants now. Okay, I think we start.
Yeah.
Yes, with our webinar now. Yes, once again from my side, welcome to our international webinar today afternoon here in Germany. So my name is Susanne and I will guide you through this webinar. Our topic today is the smart air injection, a combination of progressive cavity pump and pneumatic dense phase conveying. Yes, with this pump system, dewatered sludge can be transported over long distances of up to 1,000 meters in an energy efficient manner. So this is what I've learned today. My colleague Tobias, he will explain now how it works in detail, and I would like to hand over to Tobias. One short notice from my side. So if you have questions or comments, so please use the F and A part. It's like a chat. You see that in Zoom. So there you can write down your questions and we will answer them in between. Okay, so then Tobias, it's your stage now.
Okay, yeah. Thanks, Susanne. Also welcome from my side, and good that you found the way today into this webinar. We are very grateful for that, and that you give us the chance today to give you some more information on our new innovative product, which is called SAI, which is the abbreviation for smart air injection. So I will guide you today through this webinar and to give you some more details about SAI, how is it functioning, what are the benefits of SAI, and so on and so on. Just to give you some more information about myself, I'm Tobias Blumenhofer, as Susanne already introduced. And I'm working here at CPEX as product manager, and I'm mainly responsible for the smart air injection system. I have a background in mechanical engineering, specialized in fluid machinery, and so that you just get a feeling for who's the speaker today. And now we will jump into the topics of today. So the topic is smart air injection, what we at CPEX here call to be a revolution of the transport of dewatered sewage sludges. And today I will explain you how we want to minimize the life cycle costs with our new SAI technology. So today we will discuss on dewatered sewage sludges, also a little bit on different applications than dewatered sewage sludges, but this will be the main topic for today. Just to give you a short notice, tomorrow a colleague will also introduce SAI and how it is functioning for the brewing and distilling industry. So not only for the transport of dewatered sewage sludges, but you will see today also how you could use SAI for different applications. Okay, so the content, I will give you a little motivation. So what is behind SAI? Why are we doing, or why did CPEX invent this kind of product? What is actually the intelligent conveying concept behind SAI? How is this related to the SAI controller and the digitalization? And then I will give you also a short overview of the SAI system, the different application options, and so on. So this will be the theoretical part of today. And then the second part will be the more practical part. I will show you some case studies, give you an overview of different references and how SAI then really looks in the field. And then I will summarize on the benefits again of SAI, and that's already it for today then. So I think we scheduled 90 minutes for the webinar. I don't know if we will need the whole 90 minutes, but it depends also on you and on your end. So in the past, we scheduled one hour, but then we saw there are so many questions coming in between, so that we have the opportunity to answer all the questions. We extended the meeting, the webinar, to 90 minutes. So use the time. That's why we are here, so that we can directly answer your questions. As Susanne mentioned, use the F&A button to ask questions, and in between the slides there will be some breakpoints where I then will come back to your question and answer them. So ask them directly, so that you don't get lost on the way today, and that I can answer when you have questions. Okay, so what's the motivation behind SAI? What we here at CPEX experienced in the market were increasing requirements for the transport and in general for the handling of dewatered sludges and dewatered sludge applications. Customers need to overcome longer distances. They want to modern their systems. They require easy and fast maintenance. They have a complex process management they need to overcome on site. In some cases, you even have limited installation space. And a topic always important and getting more and more important at the time being is that you want to improve the life cycle cost of your system and improve the energy efficiency of the whole system. So on the solution here, what CPEX invented is a combination of two different technologies. It's pumping, so it's pumping by sludge cake hopper pump, what CPEX is also known for. So we are a manufacturer of progressive cavity pumps, and they can be applied in a lot of sludge applications. Yeah, so we are combining here the pumping by sludge cake hopper pumps from CPEX and support it with pneumatic conveying. So you see here one of our T-range pumps, a CPEX hopper pump, and this is combined with a pneumatic air system, which is connected to the discharge line, and also a CPEX dosing pump is connected as well to the discharge line for the usage of polymers to further reduce friction losses in the piping. I will explain this in detail, but this whole system we call as a package unit, smart air injection, SAI, and it's a combined technology and gives a system which is a hydraulic pneumatic conveying system. So actually, when you go on site and you want to transport dewatered sludges, which are normally very high viscose products with big friction losses, pressure losses in the piping, or every other high viscosity product, and you want to convey it with high pressure pumps, what you will see is you have high friction losses you need to overcome. You need a big pump, and in this case, a multi-stage progressive cavity pump with moderate energy consumption or high energy consumption. And you need, due to the high back pressure in the piping, if you pump a sludge column through the piping, and you need also high pressure rated piping. So it's a very challenging task to transport these high viscose products, and the answer to improve here from CPEX is the smart air injection system. So with SAI, we can use a small pump with low energy consumption. We can offer our customers to use low pressure rated piping, and you have, due to how this system is functioning, only low friction losses in the piping, and over the whole time a low pressure inside the piping. How does this work? So what we are doing, we pump with our sludge pump the sludge into the piping. We put into the boundary layer of the piping a lubricant around the surface of the sludge, and then when we have a sludge of a length of 10 to 50 meters, we open for a short-term duration a magnetic valve, and then we inject from our air system air into the piping, and then we transport only by air the sludge to the outlet of the piping. And we found this to be more efficient than standard conventional pumping by high pressure pumps. So what we can offer with the SAI are low operating costs in terms of energy and maintenance due to the low pressure in the piping over the whole time. We can offer low total investment with these products due to reduced pipe and fitting costs because of the lower pressure stability rating required for the piping. So you can use PN16 or even go down to PN10. You can, so for SAI, it's normally no issue to have several bends in the piping or different vertical elevations. So you are very flexible in designing your system layout with the SAI and still have an efficient transport. We can go theoretically up to distance of 1 kilometer. If it makes sense to design a system like this is another topic, but in theory it's possible. We can upscale this system to very long distances, and we can offer you, due to the smaller pumps, we can use here easy maintenance technology like our SCT technology, smart conveying technology. If you're not used to it already, I will explain later on what SCT is. But with this, we can offer our customers lower downtime due maintenance in place and increased pump life overall. And compared to open mechanical conveyors with SAI, we can offer you a closed system with a closed piping without odor and spillage. And last but not least, SAI is a package unit, and it comes along with an own SAI controller that can be integrated into your SCADA system on site. And one last point, depends on where you are located on the globe. So we are today a very international round, but in many places where you have winter times and where it's get cold outside during nights and where you are not running your system, it's very important overnight to clean the piping so that you don't have any freezing on the piping. You don't need then any pipe heating at all, but in some circumstances, a clean pipe can be a benefit in general, not only for winter times, but SAI, due to the pressure, to the compressed air we are using here, we can offer you a system that immediately is able to clean itself. So you have here integrated pipe cleaning by air as well included as part of the system. And due to the smaller pump, we can offer you lower pump footprint. So if you have limited installation space or something like this, this would be also a feasible benefit why SAI could be a solution for you. So normally first question now is, so you want to replace a hydraulic system by a pneumatic system, knowing that compressed air is very expensive. A compressor is kind of just a heating machine. So due to the law of thermodynamics, a lot of the energy gets lost into heat, not into mechanical energy. How can this be more efficient than pumping the fluid? And now give me a little bit time to explain this. It's not that complicated, but it's due to the nature of different pneumatic conveying types that are existing. And you can distinguish, and so it's also known in the literature, between different types of pneumatic conveying. So there's the lean phase conveying when you're transporting pellets or granular media or something like this. But here, for this lean phase conveying, the relation between air and the line loading is very bad. So you need a lot of air to transport small amount of medium. So you need to inject over the whole time a lot of air into the piping so that it can drag the particles inside the piping along. So this is not a very efficient conveying system. But it's necessary for some particles, so there's no other option for conveying. Okay, next type of pneumatic conveying would be the intermediate phase conveying, where you already have a kind of dense phase in the bed of the piping here. Here, the relation between air and line loading is already better, but not good. But it's already better. And then there is the dense phase conveying, and this is what we are using with SAI. So we have a high line loading and only need a small amount of air in the piping to convey the fluid to the outlet of the piping. And this is called dense phase conveying. You have a compact kind of plug in the piping, and this compact plug is conveyed by short-term, pulsed air injections to the outlet of the piping. So this can be efficient, and we achieve here still a good energy efficiency because of the high line loading and the low air consumption within this dense phase conveying. And we combine this with a lubricant film in the boundary layer in the piping around the surface of the sludge to improve the energy efficiency even further. And there's another effect. So those of you who are familiar to fluid mechanics or rheology or to some chemical investigations. So there are different flow behaviors of different fluids. And this is investigated in the rheology of fluids, and you can distinguish between Newtonian fluids and non-Newtonian fluids, what we call shear thinning fluids, like lubricants or sludges. And if you imagine you transport or if you pump water, you will always have this kind of parabolic velocity profile within the piping. But with, for example, dewatered sludges, you will have such a velocity profile like it is shown here, where the fluid behaves like a solid in the middle of the piping, but on the pipe walls where you have the shear forces acting, you will have a local temporarily shear thinning effect during transport of the sludges. So the viscosity for dewatered sludges, it's not constant, and you will find a lot of studies in the internet, scientific papers, and so on that prove this behavior of dewatered sludges, that they are dependent, the viscosity of these sludges is depending on the shear rate. And the higher the shear rate, the lower the viscosity due to the shear thinning effect. Instead, water has, depending on the shear rate, a constant viscosity, so excluding now the temperature and so on, okay? And the shear rate is proportional to the velocity, which means the higher the velocity, the higher the shear rate. And if you now imagine that with a conventional pump, you are pumping the fluid slowly through the piping, you will achieve velocities up to 0.05 meter per second. So very low velocity. So the sludge is moving very slowly in the piping, and you have high viscosities and high friction losses you need to overcome. But with the air, when we are using SAI, we are accelerating to up to 5 the sludge up to 5 meters per second, so by a factor of 100. And due to the shear thinning effect, we achieve with higher velocities higher shear rates and have a temporarily shear thinning behavior in the piping of the sludge. The viscosity is decreasing, the friction losses are decreasing, so we can reduce with this effect the viscosity up to a factor of 10. So here's an example of a shear thinning fluid. It's not dewatered sludge, it's simple ketchup. But if you put a golf ball on top of this ketchup, it will not sink in. The ketchup acts like a solid fluid, actually. But if you drop the ball from the top with a higher momentum and the higher velocity, it will sink into the ketchup, and the ketchup behaves like a liquid due to the shear thinning behavior. This is just to show you this, everybody of you would have guessed that this experiment will look like this, but this is the nature of the shear thinning behavior. Okay, maybe if you want to make an experiment at home, you can try yourself. But okay, so how does SAI now work? We have here the SAI system shown, we have here the pipeline, and here we see we want to transport our sludge into a silo. And here we see a pressure curve. So over time, how does the pressure behavior inside the piping? So if we measure the pressure here at the outlet, at the pressure flange here, this is how a typical pressure curve would look like. So we start here, at the blue line, and now our pump is pumping the sludge into the pipeline. Yeah, and then here we are injecting lubricant as well into the piping, yeah, so that we get our lubricant film. And then by time, we are increasing here the length of the plug until we reach a certain pressure threshold, which is, now I will give you some numbers so that you can imagine how the system works. So when we reach roughly about 1 to 2 bar in the pipeline, we will start injecting the air. So for a short-term duration, then the magnetic valve will open and the air is flowing into the system and transporting the sludge into the silo. Okay, this is what you see here. And what you also see here is that during the air's flowing into the piping, there is a very characteristic pressure peak. This is what you normally see then on site in the field. Yeah, the air needs a little overpressure to accelerate the plug to the higher velocity, what I just described before. And then after this, the pressure will drop again to roughly 0 bar. And then you know the sludge plug has reached the silo. Yeah. And the whole pressure over time is here below 10 bar because our air pressure vessel, we set here the pressure to 10 bar. Yeah, so when we inject the air, we have 2 bar roughly in the piping, 10 bar in the vessel. So you have a pressure difference of 8 bar. Yeah, and when you see that the characteristic peak is going up to like 5 bar, you know you need 5 bar to accelerate the sludge so that we have enough power of compressed air to accelerate the sludge. This is why we set here the air pressure vessel to 10 bar. Yeah, but this is the maximum pressure in the SAI system that is possible. Yeah, 10 bar. Yeah, but normal operation pressure is roughly about 2 to 5 bar. Okay. So this low discharge pressure, yeah, how do we achieve this? Yeah, we are injecting lubricant into the piping to decrease pressure losses. We are using the described pneumatic dense phase conveying. So we are conveying compact plugs to the outlet, and we are using the benefits of the shear thinning behavior of the sludges. So when we accelerate to a higher velocity, yeah, we can use the benefits of the rheology to decrease even further our pressure losses in the piping. And now the answer to the question, why can this system still be efficient when we use a compressor? Yeah, we are only using short-term air injections. Yeah, so if this is a cycle of 5 to 10 minutes, yeah, we have here opening, yeah, of the magnetic valve of roughly 10 to 20 seconds, yeah, time for the air to flow into the piping. Okay, so here's a live demonstration. Yeah, so this was one of the very first tests when we tested SAI. It's already quite a while ago, but still some nice videos to show. So here for this test setup, we were using plastic piping of DN125 PN16 with a distance of 500 meters and a capacity of 3 cubic meters per hour with a sludge of 22% dry solid content. You see here the piping coming out of the dewatering building, going around here, this area here around this yard. And then we are conveying here onto this yard here. And this is then how it looks like. You see here the sludge coming out of the piping. Yeah, so you see these plugs coming out and here hitting the ground. Yeah, that's a little demonstration how the pneumatic transport of these sludges can look like. And you see here the high velocity of the sludges in the piping. For which applications can SAI be used? So we have a strong relation to the wastewater industry. Progressive cavity pumps are used there, yeah, as a very standard technology. And this is why we also started with SAI in the wastewater treatment industry for conveying of these dewatered sludges with high viscosity and high friction losses in the piping. But we found out also for other industries, this is a relevant technology offering the same benefits I just explained also for other applications. So as I said, tomorrow my colleague will explain to you how SAI works in brewing and distilling industry for the transport of spent grains. Yeah, so if you're part of this industry, you should definitely join tomorrow our other webinar. Definitely worth it. Yeah, but also for these spent grain, transport SAI offers a lot of benefits. But we also found out for waste foods, yeah, SAI is an application also, yeah, offering a lot of benefits. And yeah, here's some dots. So whatever you might imagine where you are searching for a solution, SAI could maybe be a feasible solution for you. Yeah, if you have a high viscosity product, yeah, which can hardly be transported. Yeah, when you're using either mechanical conveyors to move the fluid or really high pressure rated pumps, high pressure pumps, really big pumps, then maybe SAI might be an efficient solution for you as well. And here at CPEX, we have test systems for this. We have here in Europe a test system, but we could offer this also in the United States for you, wherever you're coming from, or also in the Asia Pacific area, we could discuss on this. So yeah, empirical studies are most of the time, yeah, best way to find out when you are searching for a new solution if SAI might be a solution for you as well. So the features of SAI, just to summarize it, SAI is a system product coming with an own control system. I will explain this in more detail in a few seconds. We call it a package unit, a system solution. It contains all functional components which are designed, selected, and integrated in the SAI software. So the software is also, yeah, programmed and developed here at CPEX. Yeah, this is also our know-how of the SAI system. And what is part of the SAI system solution. Then we have the CPEX services, so application clarification, project coordination, system design, engineering, and commissioning. Yeah, so putting in all the system parameters on site during commissioning, like injection time, injection pressure, and so on. So for this commissioning, we will also join you on site and we will do this for you. This is part of the CPEX services coming with the SAI system. You could use SAI also as retrofit solution for existing CPEX pumps, yeah, or for existing dewatering equipment, or even for existing piping, depends. But we could also discuss if also for an existing system, SAI might be a solution for you that can be integrated into your existing equipment and so on to improve efficiency or whatever. So let's talk a little bit about the pumps that come with SAI. So at CPEX in our product portfolio, we have a lot of different pump types. We have the T-range pumps, which are hopper pumps, which have integrated beside our rotor and stator, which are the main elements of our pump to create the pressure. Yeah, we have with the T-range pumps also, yeah, screws and augers inside the hopper, so to transport the fluids with high dry solid content here into the compression zone and from there into the rotor stator element, because you cannot suck them in anymore due to the nature of the product. So you have here with the BTHE range, which comes along with the SAI, the centric and edge running ribbon screw. this pump can be used for dry solid content of from 20 to 40%, but caution here, these values are not to see black and white. So that we say below 20%, nothing is possible, and above 40%, nothing is possible as well. So it's just the guidance. So if you would have a dry solid content of 90%, then I would say, I'm sorry, SAI could not be a solution for your dewatered sludge, but just a guidance for which applications this pump can be used. The capacity can vary from 0.5 to 30 cubes. We recommend new piping in stainless steel or polyethylene piping, or after retrofit check, we could also discuss to retrofit an existing piping. So as I said, we can offer you an easy maintenance technology, which is the smart conveying technology. You might already noticed here. So normally progressive cavity pumps, they come along with so with an elastomer inside a tube. So this is called a tube stator, and inside the tube stator you have the rotor, which is rotating, and with this rotation transporting from the suction side to the pressure side the fluid. With the SCT technology, we have a stator that is cut in half, and you can here with these screws retighten the clamping, retighten the clamping on the rotor, and with this also the so if you have wear on your pumps, you can reclamp and then improve again the volumetric efficiency of your pump. And you have with the SCT technology also the opportunity to maintain the pump in place, so you don't need to disconnect the pressure flange and piping and so on. You can with these screws disconnect or connect just the stator halves and have here the opportunity for easy maintenance. And you can also from the joints directly dismantle the rotor, so that you also can easily exchange the rotor and stator. So if you imagine coming from a very big pump to transport high viscose fluids, this SCT technology offers you a lot of benefits compared to high maintenance pumps. Another option would be the sliding compression casing, which is here called at CPEX drive joint axis. So with this compression casing, you can move this or just simply put this away, and then you have access to the rotor joints and can directly disconnect here. This will also improve already the maintenance. Okay, what are the different SAI system options? So SAI is a customized system solution. So based on your requirements and specific application and needs, we will design the SAI system. So we have different options for the number of injection points for lubricant and also air. This is something we would consider for very long distance transportation. So for pipe cleaning and so on, we would foresee along the piping different numbers of injection points. But for the transport of the sludge, we would foresee the first injection point for the air. And for long distance pumping, we would also consider different lubricant pumps along the piping to maintain the lubricant film around the sludge. But I would say for most of the SAI applications, one air injection point and one lubricant point is the standard. Based on the requirements, the piping design and layout, we will size, and also the flow rate of the system, dry solid content, and so on. We will size the pumps and also the air components. You can order, if you're want to directly the air components from CPEX as well, or organize them by yourself based on our specifications. Yeah, for you could also use extension hopper by CPEX to connect, for example, to a centrifuge. So I skipped here the material options for the valves and fittings. Normally we use here as standard stainless steel components. You have also the option for different level control technologies. So you could use radar, laser, or load cells. And via different field bus interface standards, we can connect. And so we are flexible here, and we can connect to your SCADA system so that you are able to control SAI also out of your control room. And for all the hardware, the PLC and so on, we can offer you also from CPEX a control cabinet so that you get a complete system solution for the SAI from us. So the system overview, let's talk about the special components here. So you have the hopper pump part of the SAI system, the compressor, the air receiver. We have a special designed adapter spool piece here. Then we have here the laser level control in this example, but you could also have here a radar sensor or underneath the pump load cells. Yeah, and with these technologies, we could realize the level control. We have then also included overpressure protection. Did I skip the? Yeah, I think I skipped here the dry running. Then we have also here temperature sensor for dry running measurements, so that we can give a warning when the pump is running dry. Okay, then here a little bit more detailed sketch of our special designed adapter spool piece. So here you can screw in all the sensors that are required for SAI control. So our pressure, injection pressure sensor. Then we have here the manifold for lubricant and flow separation of the lubricant so that we can evenly distribute the lubricant around the surface of the piping. Then we have here special designed air valve set, which contains manual ball valves, non-return valves, and also main actuator here, the solenoid valve. Then we have also between compressor and air receiver air consumption measurement device to measure the air consumption. On our lubricant pump, we have also the overpressure protection and a lubricant consumption measurement device. And one thing I want to mention here, you might now ask, okay, why do I need such an air receiver? Why can I not directly connect the compressor to the piping for air injection? So normally we have cycles with a pause time of 5 to 10 minutes between every cycle. And between or in this time, we can use a small compressor who can slowly reload the air receiver. But when we open the solenoid valve to transport the sludge to the outlet, for 10 to 20 seconds, in this time, we need a rather big amount of air. So this is why we have here an air buffer in between the compressor and our SAI or our pump, or between the piping. And last but not least, all the actuators and sensors, they are integrated into the CPEX SAI controller, which is the heart of the system. It's a Siemens controller, or also it could be Allen Bradley controller. So we are offering here platform independent controls. So the controller is for visualization and monitoring of the SAI process, including fault diagnostics. From here, you can control the flow rates like sludge, lubricant, and control the air injections for dense phase conveying, control of all safety functions like overpressure, dry running, and so on. You can measure here the consumption of compressed air and lubricant, and from here we can integrate into the SCADA system via field bus communication. Okay. And on top of this, we can also connect via the CPEX pump monitor, the PLC to our, or the data to our monitoring cloud, which is the CPEX connected services. From here, you can get access to a dashboard, see all the data, the condition of the SAI system. So when you are, for example, have a center for maintenance planning or something like this, here the guys who do the planning and so on have access as well to the SAI system, have a look into the system operation, into the operation point. You can see here the air consumption, current, speed of the pump, or whatever values we are measuring in the field can be shown here. Then we can offer you here reports. With these reports, we can use our data analysis, so that you have an overview of your system. How much air did you consume within a month? How much lubricant did you consume within a month? What is your current operating point? How could you improve this operating point? So system optimization would be a benefit of this monitoring system you could set on top of the SAI, which makes for this already kind of more complex system definitely sense, but also in terms of troubleshooting. So especially in the beginning, when you set the system, when you optimize the system, and so on. So if you have there any trouble or something like this, you get a functioning guarantee from CPEX for the SAI system. But to have an immediate or a fast response time, if we or our experts can have a look into the data as well, we can offer you improved response times in such a case. And you get also with the monitoring mobile notifications and recommended actions. So for example, for the lubricant pump, if you have here some wear or something like this, you get a notification and so on. Okay, so for which dewatered sludge types of application can SAI be used? So we have installations in the field already with screw presses, belt presses, filter presses, centrifuges. We can install the pump underneath a silo for emptying, or we can convey into a silo with SAI. We can install SAI underneath a reception bunker. We can convey into solar drying systems, which especially in south of Europe gets more and more interesting. So for all these applications, SAI is a feasible solution. And now let me finalize or finish the theory part with a small animation so that you get a feeling how this looks like. So here you see our BTHE CPEX hopper pump. You see now here the air system connected to the discharge line, the magnetic valve, the pressure sensor. You see here the lubricant pump connected to the discharge line. And here you get now a view into the pump. So here you see now the auger rotating and the sludge coming from the top, conveying the sludge into the compression zone of the pump. Here you see the laser sensor now recognizing that the level is increasing and the pump is speeding up. This is then our level control system to avoid overfilling of the system. From here, the sludge gets into the rotor stator elements. We are lubricating then the sludge with a lubricant film. And as described before, we are now measuring the pressure. And when our control system recognizes that we reach the pressure threshold, we will switch and open the magnetic valve and inject for a short-term duration the air into the piping. And then this cycle repeats. And now from another perspective, you will see here the pressure peak. Actually, it's going up in this example to 3 bar, and then when the sludge is moving inside the piping, the pressure is dropping again. Here from another perspective, yeah, like a pneumatic POS system, as they were used in the past. Okay. Yes. Okay. That's the animation. And now we have here a slide with a break to answer some questions. So please, everybody who has not already written a question into our F&A section, if you have a question now, then please, now would be a good break point to answer the questions before we go into the practical part.
Okay, thank you, Tobias, for the introductional words about all the details, let me say, of the smart air injection. Let me have a look. So we have a question. What is ranges when it comes to dry solid content?
So
I'm a little bit irritated about this question, but I think you understood.
Yeah.
Yeah,
So
okay.
no. So as I said, it's depending most of the time on our pump technology. So what do we get through the pump? So as I said, depending on our pump, we can convey 20 to 40% dry solid content in regard to dewatered sewage sludges. Yeah. But as I said, you don't need to see these values as black and white. Yeah, so we can also convey a more liquid fluid. Then the question is SAI still an economical solution, or can you just pump it? Yeah, when you have very low dry solid content, yeah, at some point, then I would say SAI is not a feasible solution anymore. Just use a simple pump. For higher dry solid content than 40%, I would say it depends on the fluid. So dewatered sludge is also different from application to application. Yeah, so we can go above 40%, but yeah, the drier and the higher viscose the product is, I would also say we need a little more lubricant. And but if you imagine a completely different type of sludge, like we have also experienced in the past with mineral sludges, so not from the wastewater treatment industry, there the dry solid content did even go up to 70%, but the flow behavior was still quite good, so that we could use SAI here.
Okay, thank you. Another question arises. Can you convey in silos? Are there limitations regarding height or changes in direction?
So, okay, that's also a good question. Yeah, so you are normally free to choose your pipe outlet. Yeah, so you can convey into a silo, we can convey onto a sludge yard, we can convey into a container, we can convey. So, yeah, the only thing is we cannot convey into a completely closed system. Yeah, because there needs to be a vent or something like this that the air can go out of the system. Yeah, so this is the only requirement coming with SAI. In terms of vertical elevations, we have silos going up to 20, 30 meters, but where's the limitation? I think there we can even go up to higher vertical elevation. So the thing is, once the plug is accelerated, vertical elevations, yeah, are easy to overcome.
Okay. Another question, can water be used as a lubricant? Should lubricant be like oil?
So So generally, yes, we could also imagine to use water. So the thing is, why are we using, I said in the presentation, we are using polymers. The question is, why polymers? So on the one hand, in a wastewater treatment plant, you have these polymer station, which is used during the dewatering process. So these polymers are available on site anyway. That's why we are using them. And these lubricants are most efficient. Yeah, so we have also studies on this, and can find also studies on the internet. So which fluids are most efficient for lubricating in terms of reducing friction losses, and polymers are more efficient than water, so that you need to inject less polymers than you would for the same effect need to inject water. So then the second part of the question, can oil be used? So I don't know your environmental restrictions where you are coming from. So I don't know if oil is from an environmental point of view possible, but I think from a technical point of view and in reducing friction losses, I think yes.
Okay. So we have some more questions now. Next one. Is it possible to replace the polyelectrolyte dosing with only air for short, for example, 20 to
Yes.
30 meter
Yes.
range of transport? Yeah.
Yes. Yeah. So for short distance conveying, like only 20 or 30 meters, yeah, okay, you would need then more air than you would need if you use the polymer system. But for short distances, we could leave it out. Yeah, depends on the fluid, but depends also on the fluid. If you have a really, really dry fluid, like 40%, then I would say maybe for safety and for most efficient conveying, I would still maybe insist on the lubricant, but for not so dry fluids, I would say yes.
Okay. Then another question. When compressed air comes on, does the PC pump stop? And does the knife gate valve need to close?
Yeah, this is a question that comes up very often. The answer is the knife valve does not need to close. Yeah, and the pump is during this process still running. Yeah, and so this is how progressive cavity pumps work. You have between the rotor and stator a sealing line. Yeah, and this sealing line avoids the air or the sludge going, yeah, into the other direction. Yeah, the air is going the way of less resistance, which is the pipe outlet. Yeah, so if we have 5 bar in the piping, the sludge will always go to the outlet when the pump is running, because the pump can, depending on the pump, go up to 12 bar, 8 bar, depending on the pump we are using there. Yeah, but generally the pump acts like a valve. When it's closed, it's closed.
Okay. And then another one. We have seen in slides that long distance, you have air injection point required. Does that also mean extra ring lubrication injection?
We have so there would be then an inlet or a connection also to inject the lubricant. Yeah, so yeah, yes. In this case, then yes. If we say we need one, depending on your application, yeah, then we need also the diverter. Yeah. Or we could discuss, yeah, just to simply use one connection. Yeah. So we are flexible here.
Okay, so thank you for answering. These were the questions so far. currently.
Okay, yeah.
We can go further on, but feel free, yes, to write your questions down during the next part. Okay, then let us go further on. Yeah.
So I will go ahead, with a look on the time. So I will try to keep it short and not too boring, but no, we have seen a lot of theory and a lot of benefits I claimed you have with our SAI system. But now what is missing is the proof of this concept. And that's why I put some case studies in here to discuss with you today. So to give you a feeling of the efficiency of the system and what are the costs and how does it compare to other technologies. So let's go ahead. So generally we have in the meanwhile a lot of SAI references in Europe, where we started initially in 2017 by launching SAI. But we have now also installations in the USA, but also in China. But yes, our core, because here we started the launch, is still Europe. In total, we have here over 90 systems of SAI already sold, also to some customers or names that might be familiar for you. So we have an installation at Veolia, at Suez, at Thames Water, but also at Bioforce in Denmark. So big water authorities have already SAI installed on their site for the transportation of dewatered sludges. And we see more and more interest in the market for this technology. So let's come with a case study from Germany. It's a Sende, it's a municipal wastewater treatment plant. So here we have dewatered sludges up to 29% coming from a centrifuge, and we are conveying here into a sludge outlet, like a hall here. Here you see the SAI system, our BTHE pump with SCT technology. Here you see the lubricant injection, and here you see also the air injection. And we are using here laser level control technology. Pipe length is 250 meters, capacity going up to 2.5 cubes. Here again, from another perspective, you see here the dewatered sludge falling from above, from the centrifuge into the pump, and is then conveyed into the pipeline. And the piping is here, or it starts here at the centrifuge coming from the dewatering building, and then conveying here underground 250 meters piping, even below this river here into the hall 1 and hall 2 into the building here. And the initial condition here was that the customer had a piston pump in use, and their pain was that they had significant maintenance and energy costs. They had an installed driveline up to 45 kilowatts here, and during startup phase of the system, they had realized 80 bar in the piping, and in operation 70 bar. And I don't know where was this shown. Okay, no, this comes on the next slide. Sorry for jumping. So, and the maintenance cost for this piston pump was 15,000 euros a year, which is already a lot. And they had also to inject 300 liters of water to convey the sludge into the building 250 meters away, to make it pumpable at all. So the CPEC solution we foresee here was our smart air injection system with single stage SCT pump, with 7.5 kilowatt drive, with lubricant injection and also compressed air. So the challenge here was they had installed a steel pipe DN200, PN160, so really high pressure rated piping because of the piston pump installed underground. Unfortunately, during reconstruction, the steel pipe was open to atmosphere, and they had some severe issues with surface corrosion, yeah, and partly also pitting corrosion here, yeah. So the problem here was due to this corrosion, we had some increased frictions, and it was also for the SAI system more difficult to push the sludge through the piping. Yeah, but nevertheless, SAI is now running here since 2019, and since then they are using the system. Yeah, so especially in the first 2 years, we are now in the fourth year. So I would need to ask our sales experts if they are still running without spare parts, but in the 2 years they were completely running without spare parts, which was already a giant step forward compared to the piston pump. Yeah, and here you see also the pressure curves. Here we have the pressure inside the air vessel. So when we are injecting air, the pressure is dropping, and here we see the pressure in and along the piping. So we had different positions where we measured the pressure inside the piping. So we have had here position hole 1 to hole 3. Yeah. And you see when the air is injected and the plug is transported along the piping, then you see here the first pressure increasing, the second one, the third one, the fourth one, the fifth one here, 1, 2, 3, 4, yeah, 5, sorry. And then when the plug leaves the outlet, the pressure is immediately dropping, so the pipe is cleared and the sludge has reached its destination. And the cycle, yeah, we have an injection roughly every 15 minutes. Yeah. So, okay, I just want to show you a video. So you might now ask, how does it look like when the sludge enters the building here? So you see here this smooth breathing of this sludge hill. Yeah, so the sludge enters very smoothly the building. Okay, so let's discuss the life cycle costs a little bit. So the Stadtwerke Sehnde, so the municipal wastewater organization here, they gave us their life cycle costs they had for the piston pump, and we compared this to the new SAI installation here. And you can see here, compared to the piston pump, yeah, we could reduce the maintenance and spare parts costs significantly, and we reduced also the power consumption. But also we reduced here the lubricant costs a lot. Not only the purchase cost, but also the disposal cost, because here in Germany, you pay for disposal of these sludges, and when you add water again to the sludge, you are increasing your disposal costs as well. Yeah, so this is what you are here also have a lot of savings. Yeah, but as I said, we had to use the existing piping, which was corroded, which is not that efficient. That's why I mentioned it before. Yeah, we had compared this to a plastic piping where we could further reduce the lubricant injection, yeah, and therefore also the lubricant costs. In total, we could save from piston pump application to plastic piping, 88% in terms of maintenance and roughly 50% in terms of energy. So we have a lot of savings here with the SAI technology. And what is neglected here, if you are planning a new system, and you plan to install a new piping, it makes for your investment a big difference if you install PN16 piping or PN160 piping. Yeah, this will make a big difference. And here we have shown over 10 years your savings, compared SAI to the initial piston pump, so the red curve against the blue curve. So you can save here over 250,000 euros in this period. Yeah. So this was the Stadtwerke Sehnde here in Germany. We have another example from the UK. where we have already also a lot of SAI systems installed in the meanwhile, especially for the big water authorities like Thames Water, Reading, a very big sewage treatment plant in the UK. Yeah, so the plant condition here looks like this. You have here also the sludge coming from a centrifuge into the pump. So the dewatered sludge from a centrifuge, and then here transported along the piping. Here is the air injection. Yeah, and then we have here also 3 different destinations where we can transport our sludge to. Yeah, so we have here silo A, B, or C. The data here, sludge capacity 3.5 cubes, up to 25% dry solid content, DN 150 pipe diameter with PN 120 pipe pressure rated piping. Pipe length 53 meters, 18 meters vertical, and 10 5D bands in the piping. And the status quo was that the customer here had also, big pain due to the piston pump, which was unable to handle the 25% dry solid content sludge, and which exhibit enormous maintenance and energy cost. Yeah, that was the initial situation. Then CPEX installed a multi-stage progressive cavity pump, 8-stage pump. So you see the size of the big rotor and stator here as well. So it's definitely not a small pump. Yeah, it needs also to overcome big pressure. But we combined it here with a lubricant pump, to reduce the friction losses already to an acceptable level. Then we installed a trial installation, a mobile compressor, just for testing. And this was first trial installation here, where we then tested the SAI with the multi-stage pump and the BLI. And the optimum solution here for this application would be a one-stage SCT pump with BLI and SAI. We have here a very similar application on another side, which we can use the data to refer to. So this is what we have done here, and we compared the energy savings from the piston pump to the multi-stage PC pump to the multi-stage plus air to the one-stage SCT and air. So we have already achieved a big savings, so a big step forward compared from piston pump to the multi-stage progressive cavity pump. But we could even improve with multi-stage plus air. So from 27 kilowatt roughly to 7.4 kilowatt. But here you have then on top the power for the air consumption, which is here 2.6 kilowatt. And then we have here the rating for the one-stage SCT plus air, which is here roughly about 3 kilowatt with 4 kilowatt air on top. And these were measure results. This is based on a similar plant. And with this, you can save up to, from the piston pump to the SAI system, 72% in terms of energy. But don't forget the operating pressure. Piston pump coming from over 60 bar. We are now down to 2 bar in operation, which is a big step. But even compared to the multi-stage PC pump, we normally can experience for those applications up to 40% in terms of energy savings. Okay, also here Thames Water, they were open to give us also here data on their piston pump and what they have consumed here in terms of maintenance cost, energy cost, use of polymer. So they used the piston pump without any lubrication, which we had to add with our pumps and with the SAI. Okay, but you see in total, compared to the piston pump, we can save 80% in terms of maintenance and 72% in terms of energy. And over 10 years, also here, we have 40,000 £100,000 in cost for the SAI to £180,000 for the piston pump. So we had here also savings up to £140,000 in this period of time, but also neglected the investment in piping. This was also here a retrofit application, PN 120 piping, compared to PN 16 or PN 10. If you would plan a new system with a new piping, you would here achieve a lot of saving in your investment. Okay, last but not least, Osberstone, Ireland. This is an application from Veolia. I like this application because it shows you how flexible you are in designing your process with SAI, especially due to the also smaller pump footprint we can offer you. So the challenge here, the intention for Veolia was they wanted to exchange their thermal dryer system to an anaerobic sludge digestion combined with the thermal hydrolysis process, in order to save CO2 emissions. The challenge here was to integrate the new process into the existing building. And the existing building was originally designed for 2 sludge dryers. But now they had to fit in the new sludge dewatering system with 3 belt filter press, a new polymer preparation station, and the THP process. And Veolia had or has designed an Excelis process which already can reduce the installation space required for THP, but there was still not enough space for conventional sludge pumping systems. So, and here's the layout. We have here the silos, the 3 belt press, and here we have the 3 SAI systems. So there was not enough space for big pumps, but with SAI, they could fit the whole process completely into the existing building. And also here we compared internally the SAI against our 4-stage pump in terms of lubricant consumption, energy savings, and also spare part costs, and came to the conclusion here as well that we have savings in terms of maintenance and energy as well, up to 64 and 40%. Sorry, these words are here written in German. I need to change this. Okay. And also the project manager from Veolia, Alan Whitty, and we are allowed here to use his phrase. He said, and these were his words, that, he said, I have worked with sludge cake pumping systems for 17 years, but I have never seen anything like the SAI installation at Osberstone. I'm extremely impressed with it. And Veolia, since then, we are also now in discussion with them for other SAI systems. So I think they were very happy here. But you are also allowed, or we are allowed to give you also the references from Alan Whitty, and we have also the references of other customers. So if you are interested in get in contact with other customers that are using SAI, and not only to hear our opinion on SAI, we can give you a reference list with other customers. They are already using SAI as part of their daily business. Okay, these were only 3 case studies. Now, last but not least, I put together some references to show you a little bit the flexibility of SAI, so that you might see a system where you say, oh, this would be an application for me. So let's start here with a small reference list. So wastewater treatment plant, also municipal wastewater treatment plant Kaufbeuren in Germany. We have here also installed 1 SAI system with centrifuge sludge going up to 33% dry solid content, piping 40 meters, 20 meters vertical. You have the pump here also installed in the basement underneath the centrifuge, conveying into these or the other silo here. You have here the control valves to switch the destination. You have here the controller. Here the pump, including the hopper, and here you see the air station. Flow capacity 4.5 cubes. So another treatment plant in Germany in Plauen. So characteristic for this application is that we did not supply our PLC or our PLC hardware, not we supply a control cabinet. So we were only supplying software, so functioning blocks that were integrated into the overall centrifuge control system. And yeah, this is also a dewatered sludge application with a centrifuge up to 25% DS. Here you see the air injection valve, you see here the lubricant injection diverter, and you see here the lubricant pump. Flow rate up to 6 cubes, piping only 30 meters here and 20 meters vertical. Okay. Then Optibig, this is a reference in Belgium. Here we are already conveying up to 150 meters, DN200, flow up to 8 cubic meters per hour. So here you see we used 2 lubricant pumps, but yeah, so for this longer distance of 150 meters, we have connected here also the second lubricant pump, but I think it's not in use. So we foresee this lubricant pump, yeah, but we found out, yeah, during system optimization on site that it is not really required. You just use a little bit more air, and it was also working for the 150 meters. Yeah, so we you see here the visualization of our Siemens PLC. Here you see the CPEX BTHE pump with the air injection set and the lubricant diverter. And you have different destinations you can choose here with the automated valves. So you can either convey into one of the 4 containers or into a silo. Flow already up to 8 cubic meters per hour. So wastewater treatment plant Hedlingen, I think it's one of the biggest SAI systems in Germany, going up to 15 cubes. We have here 2 parallel SAI systems, each with an own control system, own control cabinet, and separate air systems. Yeah, you see here one of them and the air components. Yeah, you see here the lubricant diverter, the air injection set, and also the lubricant pump. Also sludge from a centrifuge with 25% dry solid content. We also exchanged here an existing piston pump. We have also here a case study with some more detailed data if you're interested in it. And we have here savings also up to 30–40% in terms of energy. Compared to the piston pump. Unfortunately, we have no data for the maintenance costs here. Here, CPEX supplied SAI as complete solution, which means we also delivered the piping and the cabling. Yeah, and here you see the new stainless steel piping going into the silo. You see here the controller, which is here our old BNR control. You see here our control cabinet as part of the SAI system. A reference for already longer transportation, but with a thinner sludge with 20% DS, Pinghu in China. So here you see a short, how it can look in China, such an installation. Here they had already a central air system we could reuse. Yeah, we supplied then the control cabinet, the lubricant pumps, the hopper pump, and flow also not so high, 2 cubic meters, but 300 meters total length and 225 meters vertical, and we are conveying here into the top inlet of a silo. Yeah, here a reference of Suez, Napoli North in Italy. Here we are also conveying into 2 silos. Here you see 3 systems in parallel, 4 cubic meters, 25 meters piping, and here you see our control cabinet. Yeah, Göppingen, also a municipal wastewater treatment plant, but a good example for where we exchanged a mechanical conveyor. So here the customer had installed, you see it here, an old mechanical conveyor, and here you see now our SAI system beside this. So the flow capacity is going up to 17 cubic meters per hour, only 20 meters piping, actually 50 meters vertical. But the installed power in total here, 19 kilowatt. The replacement was 35 kilowatt drive chain conveyor as shown here. And they had here also big pain in terms of high maintenance costs, over 100,000 euros in 10 years. So roughly 10,000 euros per year. Yeah, another example, Schlitz, also municipal wastewater treatment plant in Germany. Yeah, I just want to show this to you because it's a solar drying system. So we are conveying here into a solar dryer system. You see the piping here on top, and from here we can distribute evenly and very smooth the piping here on the ground. And from here, the automatic mechanical pick will distribute over the whole yard the sludge so that it can be dried. Yeah, Volkach, also an example from Germany. I took this example because it's a good one, because the customer here used complete plastic piping, which is also possible with the SAI system. So we are using here polyethylene piping. And you see here, then we are conveying onto a sludge yard, and the pipe was installed under the street here. Yeah, before this, the customer was using a conveyor belt that unfortunately blocked the access to the road. So every time a car came across, they need to move the conveyor belt. So this was maybe not the best solution in general. So this is why here the customer was very happy with the SAI system. And last but not least, an installation in France, Besançon. Here we also replaced an existing piston pump with the SAI system, which was installed underneath a bunker. You see here the control cabinet with controller, and here the SAI system. So let me summarize today. So the SAI system enables media transport up to 1,000 meters with low operational costs, very low downtime since increased service life of the pump and easy and fast maintenance in place. We can reduce the low total investment by using PN10 instead of PN120 piping. You can add on top the process monitoring with continuous system optimization, so the CPEX connected services. And with SAI, compared to open mechanical conveyors, you have no issues, so less odor and spillage and good pipe cleaning capabilities. So yeah, thanks to everybody who is still here for taking your time and for listening. I hope that I could make it interesting for you. And now we have still some couple of minutes left to answer your questions.
Okay, so Tobias, thanks a lot once again, also for all these nice references. Okay, yes, we have some questions here. So let me start with the first one. In order to size the diameter of the sludge line, what would be your recommendation regarding the sludge velocity in the pipe?
So this, yeah, so generally we are using normally DN150, DN200 or DN250 piping with the SAI system. Yeah, so it depends on the flow capacity, which diameter we are using. Rule of thumb is, yeah, for capacities up to 5 cubes, we could use DN150. Above this, we would then use DN200, and then for higher flow capacities, DN 250. So we are here referring to the hydraulic process where we fill the piping with sludge. Yeah. Yeah, to meet these requirements of roughly about 0.1, 0.05 meter per second velocity in the piping. Yeah, during the pumping phase. For pneumatic conveying, then accelerating to higher velocities. Yeah, this is not so here there is no requirement on the diameter.
Okay, thank you. And another question, have you tried your system on transporting screen grid, high solid content, or does it passes through too much air?
Sorry.
It's about screen grid.
Screen grid. Okay, so I'm actually
deep split in German. Sorry, I
okay.
I had a look in my dictionary what it is.
Yeah.
Yeah.
So what application is this screen grid? No, I get it.
Yeah.
So we are talking something, okay. So actually, to be honest, we haven't yet tried our SAI system with this. Yeah, so we have no experience this. So what is the dry solid content for this screen grid actually? Can you specify this a little more? Contains it a little bit water or it's up to 80%? Oh, up to 80%. Okay, that's already really high. The question is if we would convey it pneumatically, then I think it would work, but you are more on the side of the lean phase conveying then, yeah, because these very dry media is like a granular or like a powder then. And the question is 80% dry solid content, screen grid. I think our limitation would be here, our pump. Yeah. So I think I would check with our pump experts internally, but I don't think that we can pump it. Yeah, and I don't know if we have already pumping experience with this, to be honest. Yeah, so definitely I can follow up on this and come back to you if you like. But I would need to check if we have any experience in pumping such a fluid.
Okay, but I think it's no problem. So please write an email to Tobias and he can check this.
Yes, so I think after the webinar, you can click on contact us or something like this. If you do this, you will get my email and can contact me directly. Yeah, if you want to follow up on this.
Yeah, okay. Another question, we have one more. And how about elbows? Is it possible to install 90-degree elbow to the pipeline?
Yes. Didn't I show references with 90-degree elbows? But so yes, here, 90-degree elbows, 90-degree elbows. So yeah, we can install it and use it with SAI. The only issue or what we prefer to use, and this is part of our specification or recommendation, we use normally 5 times the diameter bends minimum. Yeah, because with shorter bend radius, you have too much impulse losses in the bend and the system is not running that efficient anymore. And you have a higher risk of blockages. Yeah, especially, so I wouldn't exclude completely that we can use shorter radius bends, but not at the beginning of the piping where the plug is accelerated. This could result in problems. So we normally recommend you with your piping to use 5 times diameter radius. And so, yes.
Okay.
Any further questions?
Currently, no. So we have no more questions.
So use the time for questions. No, we can clarify them. Otherwise, I think, Susanne, they can ask questions afterwards, right?
Yeah, yeah. This is no problem. Yeah, and you will get afterwards the video recording of today afternoon here in Germany. So then you can also have a look once again, or you can also give it the link to a partner. And if you have more questions, so please contact us, and we are sure we can answer it. Okay. Yes. So then enjoy the afternoon, the evening, or maybe the morning, wherever you are. And we hope we will see us again in one of our next webinars. You will get an invitation from our side. So thank you for your attention. And then we would like to close this webinar for today. Bye-bye.
Thank you. Bye.
Bye.